All right, Year 10, I'm going to go over what I did in class today because I made a mistake. Not with the surface area of a tetrahedron, but with the volume of a tetrahedron. So I want to go over where I made that mistake, but I'm going to go and I'm also going to do the surface area of a tetrahedron just in case you had trouble understanding it today. So here's my tetrahedron down here, and as you can see, it's 4 equilateral triangles. So the surface area is pretty easy. It's going to be 4 triangles. And I know the formula for the area of a triangle. It's a half the base times the height. So let's look at one of these triangles. And here we have one here that I drew. And I'm just going to give it a side length of A. I'm going to drop a perpendicular down at 90 degrees. It splits the base. It also splits the angle there. Because it's an equilateral triangle, we know that that angle, the whole angle is 60, so that angle will be 30 degrees. That's going to become important later, but not right now. So this is a half A. Righto. So this height here with Pythagoras, h squared equals a squared minus a half a all squared. A squared minus, well, half times a half is a quarter. A squared. And I've got 1 minus a quarter. Well, that's just 3/4 a squared. So that's what h squared is. So h equals the square root of all that, 3/4 a squared. And I can do those individually, root 3. The square root of a squared is just a, and the square root of 4 is 2. So there's my perpendicular height. I'm going to use that quite a bit. That is important. So we go back up here, and we go to our formula, and we get 4 times a half times the base, well, the base is just A, and the height, well, we just work that out, root 3 on 2 A. And here we get a little bit of luck because 2 times 2 will cancel with the 4. So our whole answer is, for the surface area, root 3, and the A times A gives us A squared. So there's your surface area of a tetrahedron. Fantastic. What about the volume? This is the one where I messed up today. I only messed up in one part. The volume of a tetrahedron. Well, we're lucky. We know it's a pyramid, so it's a third the area of the base times the height. Now I'm going to use a different letter for the height here. I'm going to use a capital H so I don't get confused. Well, we just calculated the area. The area of one of these triangles is over here. Here it is. It's that bit there. There we did 4 of them, but we only want 1 of them. So 1/3 the area, which is half A times root 3 on 2 A. But I've still got to find this height. Now the height of the tetrahedron, let's go over here. Here's my tetrahedron. What I need to do is find the height to that point. That's a terrible start. And that's my big H. Well, I can use Pythagoras if I can find out how far in it is, and I've already got the slant height, It's this over here. That's the slant height, root 3 on 2a. So all I have to do is find that bit there, and I can use Pythagoras to do it. Now, this morning I said, well, that distance is just halfway. It's not. And here in your textbook is an example. Now, they just tell you, all right? They just tell you that this is the case. And you can use, they'd say, you can use Pythagoras' theorem to prove it, but it is tricky. But I'm going to do it using trigonometry. So here's this one here, and I want to find the middle. Now, it's sometimes called the orthocenter, the circumcenter, or I think there's another one. I'm not sure exactly. I'll have to look it up. I know I've got it. There are 3 names for finding the center of a triangle. And what we're going to do is we're going to use the altitude. So watch this. If I draw an altitude from here, we already know that the altitude splits the base and splits the angles. And if I draw the altitude from here, and then the altitude from here. Now, not all altitudes intersect at one point, but because it's an equilateral triangle, they do. And there it is. And it's pretty obvious, even though I've drawn this pretty roughly, that that is not halfway. But we know that all these distances are the same. Now, what I'm going to do is I'm just going to focus on this triangle here. Now, I know that this angle in here, well, it's a half of the whole angle. The whole angle's 60, so that angle is 30 degrees. Remember, I'm trying to use the one measurement, and the whole side length is A. So this distance is a half A. And I want to calculate how far this is. I want to calculate this distance. I'm going to call it X because I've got too many H's somewhere else. Now, we've done trigonometry. We have a right angle triangle. So we can say tan 30 equals X on a half A. Now remember, tan 30 is a number. Now, this is where you're going to have to take me on belief that tan 30 is equal to 1 on root 3. You can try it on your calculator, but it is. Tan 30 is 1 on root 3. If you go to your calculator, which I'm pulling out now, and you go tan of 30, and you get 0.577, and you go 1 divided by root 3, yep, you get the same number. So trust me, it's true. And that equals X on a half A. This is now an equation. I'm going to multiply that half A across. So I get a half A times 1 on root 3 equals X. Therefore, A on 2 root 3 equals X. Now we know the whole height. The whole height is root 3 on 2A. Now you haven't done surge yet, but I can tell you that if I multiply this by root 3 on root 3, I will get root 3a. Root 3 times root 3, that will be 3. So I'll get that times, and I've specifically written it like that because it's the same as over here, except it's a third. It's a third more. So x, if I bring that third out the front, it's a third root 3a on 2. It's a third of the way in. So, can you do it using trig? But over here in your textbook on page 58, it says, now that I've got that, now I know that that distance is a third root 3 on 2a, I can now do it properly. Now remember, last time we did a half, or this morning I did a half. So, up here, I write root 3 from a, hold on, I don't write there yet, I've got to do a bit of Pythagoras. So, here's what I've got to find. If I look back here at this tetrahedron, and I'm going to draw the triangle in green. There's the big height I'm trying to find. There's the slant height of the triangle. And that's my root 3 on 2a. It's a third. Here's my big h that I'm trying to find. And this is root 3 on 2a. Just the normal slant height. So, I'm going to go to black because it's easier to see. Big H squared equals root 3 on 2a squared minus root 3, and 2 times 3 is 6, a squared. So just make sure you know that's root 3, a, 2 times 3 is 6. I'll put the third there so you knew it was a third of the height of the triangle of the base. So root 3 squared is 3, a squared is squared, 2 squared is 4, minus root 3 is 3, or root 3 squared is 3, a squared, no worries, 36. Right, so I need a common denominator. So I'm going to times this one by 9 to get a common denominator, which gives me 27a squared on 36 minus 3a squared on 36, which gives me 24a squared on 36. Oh, I know 6 goes into both of those. 6 goes into that one 4 times, 4a squared on 6. Oh, I should have done 12. And 2 goes into both of them, so I get 2a squared on 3. But that's what h squared is. I've got to square root that, so h equals the square root of 2. Well, I'll just leave that as root 2. The square root of a squared, and that's just a. And the square root of 3 is root 3. Now, so that's my height. So I'm going to put it in here. Root 3 on root 2a. That's what it is, root 3. Root 2 on root 3. Root 2 on root 3. Now, I'm lucky because I can cancel some things. I can cancel the root 3's. And I'm going to get, as my answer, root 2 a cubed three times 2 times 2 is 12. And that is the formula for the volume of a tetrahedron. If you looked up the internet, you would have seen it. Root 2 a cubed on 12. There's your volume. So I'm sorry for the mix-up today. There's your volume. There's your surface area. There are your two formulas. And that was pretty heavy stuff. And it all comes from the mistake I made of saying that that's halfway. It's not. As you can see from the diagram, that's 2/3 of the height, and this is 1/3 of the height. Now listen, that's a lot of stuff. I don't expect you to, well, for the octahedron it's easy because you've got a square. You've got a square base, and finding the middle of the square base is easy because you can do Pythagoras and it's rather simple. You might have a go at that yourself. Anyway, that's it. The formulas for the volume and the surface area of a tetrahedron. And I know those volumes are right because I did look them up, and sorry for the mistake this morning.